Route planning.
First step in ETOPS planning is to define the route. Let us consider a two-engine airplane operation from New York to Madrid. For the purpose of this lesson, we will assume a great circle routing is desired. Our next step is to identify the adequate alternate airports along this route. An adequate airport is one that meets FAA airport certification standards, meets the airplane's performance requirements, and has adequate ATC communication and navigation aids. For an adequate airport to be used for dispatch on the day of flight, it must also meet the requirements of an ETOPS alternate airport. An ETOPS alternate airport is an adequate airport with forecast weather conditions above ETOPS planning minimums and RFFS response capability of ICAO Category 4 or higher. ETOPS weather minimums are a function of the landing aids available at the alternate airport. For an airport with one instrument approach procedure, the ETOPS planning minimums are an additional 400-foot ceiling and an additional 1-mile visibility above the lowest authorized minimums for the approach. For an airport with at least two instrument approach procedures to different runways, the ETOPS requirement is an additional 200-foot ceiling and 1/2 mile visibility above the higher minimums of the two approaches used. The two approaches may be on opposite ends of a single landing surface. If an authorized Category 2 instrument approach procedure is available, the ETOPS requirement is a 300-foot ceiling with 3/4 of a mile visibility. Or for an authorized Category 3 instrument approach procedure, the ETOPS requirement is a 200-foot ceiling with 1/2 mile visibility. Forecast winds must also be within operating limits for an adequate airport to be used as an ETOPS alternate airport. Once the adequate airports for a route have been identified, we can draw circles centered on these airports to determine the allowable area of operation. The radius of each circle is a function of the selected engine inoperative diversion speed and the maximum diversion time. This radius is also called the diversion distance. The diversion distance is the distance traveled for a given diversion time and diversion speed following an en route engine failure. A thrust-limited drift down from normal cruise altitude is included in the diversion profile. The diversion distance is computed for a standard day in still air. The distance will be greater if a larger diversion time is chosen or a higher one-engine inoperative diversion speed is used. ETOPS diversion distance table is typically supplied in Chapter 2 of the Boeing Flight Planning and Performance Manual for most airplane models. For newer models, ETOPS diversion distance information is generated by the airline using manufacturer-supplied performance software tools. The FPPM diversion distance table, or airline-produced diversion distance data, is used to determine the circle radius and therefore the allowable area of operation. In this example, we will look at 60-minute circles, as well as 120-minute and 180-minute circles. With 60-minute circles, a non-ETOPS operation, the routing cannot be direct. With 120-minute circles, a direct routing can be scheduled. As you can see, 120-minute ETOPS approval provides economic and operational benefits for this route. Now consider the possibility of an en route alternate airport being closed. In this case, the displayed routing would be required to meet 120-minute ETOPS rules. However, if 180-minute ETOPS has been approved for the airline, a direct route would again be possible. For ETOPS beyond 180 minutes, 2 additional en route alternate airport requirements must be considered. First, there must always be an adequate airport within the ETOPS area with an RFFS response capability of ICAO Category 7 or higher. This requirement is in addition to the RFFS 4 minimum capability for designated ETOPS alternate airports, which was discussed earlier in this lesson. Note that local firefighting assets may be used to meet ETOPS RFFS requirements if a 30-minute response time to the alternate airport can be demonstrated. Airlines must also develop a passenger recovery plan for ETOPS operations beyond 180 minutes. This plan should provide for the shelter and physical care of the passengers following an en route diversion, and for their prompt recovery from the diversion airport in possible extreme weather conditions.